Hello learners, I am Dr. Subodh Kishorwani, working with Indira Gandhi National Open University. The topic which I am going to talk today is Introduction to Operating Systems. Prior to going into the depth of this topic, I just want to throw a light what exactly the operating system is, and this had been originated from the computers. Then we computers had been bifurcated into software, and then software into system software, and this application software. So we have already have a very thought-provoking session which talks about what is application software, and today we are going to talk on the system software. So when you more go into the depth of the system software, the role of operating system is quite important, because the operating system not only execute the whole process, but somewhere runs the systems. So if there would be no system software, no operating systems, you are not able to work on your application software. So it's a prerequisite of application software to have a system software. Either it could be the computer, or it could be a laptop, or it could be a mobile phone. Because what we observe that in a smartphone also there are certain operating systems which are quite omnipresent. Android is one of the operating systems which is working in smartphones. So for Apple we have Macintosh or other operating system. We will definitely talk more about these operating systems, but prior to go into the depth of that, we just want to throw a light what exactly the fundamentals of operating systems, because there are certain fundamentals, there are certain basics of operating system. What software is included in a system software? Because when you talk about the system software, there are certain questions which are coming up, rather you can say the objectives. What are different kinds of operating systems, and what are most common operating systems? Like Windows is one of the operating systems which are usually used in the computers, or Linux, or the Red Hat is also there. So if you go more talk about the operating system, the operating systems is the most important program that runs on a computer. I have already talked about every general purpose computer must have an operating system to run other program, because if you don't have an operating system, if you don't have a system software, you're not able to work on your application software. So application software are quite confined, or you can say it is designed for the particular purpose. But on the other hand, these system softwares are able to run the programs. So computer operating systems perform basic tasks such as recognizing input from the keyboard, sending output to the display screen, keeping tracks of the files and directories on the storage device, and controlling peripherals device such as printers. So it is linked with that. And right now the way we are transferring the data, this operating system is quite important, because if you don't have an operating system, you are not able to run the internet, you are not able to run your Internet Explorer, or Google Chrome, whatever it could be. So for large system, the operating system has even greater responsibilities and powers. It is like a traffic cap. It makes sure that different programs and user running at the same time do not interfere with each other. The operating system is also responsible for security ensuring and that unauthorized users do not access the system, because it is somewhat password enabled or account settings are into it. So it become a user specific after a certain time. So what is an operating system? Like, though I have talked a lot about, so if you go into the standard definition, a program that acts as an intermediary between a user of a computer and the computer hardware, it is called operating system. And what are the goals of operating systems? It executes user programs and makes solving user problem easily, makes computer system convenient to use, because if the hardware is there and if there is no software, ultimately the computer is not going to boot. So hardware, no doubt, is quite important because it have a physical appearance, but software role is also as good as into it. So use the computer hardware is an efficient manner. And if you see, we have a user application. If you see this particular image, you will find out there is a user, there is an application, there is an operating system and hardware. It works as a bridge to perform better interaction between application program and hardware of the computers. Examples of operating system I have talked about, like MS-DOS was the Microsoft DOS was the initial basic operating system. In the beginning stage, we have Unix, then we have MS-DOS, then MS Windows, and now certain versions had come up. Either it could be 98 or Windows 7 or Windows 10, and then there are Macintosh operating system, which is exclusively designed for the particular machine, like Apple machines are there. So the OS acts as a host of application program that are run on the machine. Almost all the computers are are using the OS on the same type. Either it could be the mobile operating system which is equipped with the Android, or the computer operating system which is having a Windows, Linux, or if the machine Apple machine is there, so it is using that. So operating system usually come preloaded on any computer you buy, and it's a licensed version, and one has to pay. Sometimes the license is for the particular time frame, and sometimes the license is for perpetual in nature. So most people use the operating system that comes with their computers, but it's possible to upgrade or even change operating system. So what we observed that the three most common operating system, as I was talking about, which is used in the personal computers or in the desktop or in laptops, are Microsoft Windows. Then you have got Apple Mac, OS X, and Linux, which is in open source. So when you talk about the open source, there are certain good points are that you don't have to pay the license fees, and Linux is something which is providing this platform in a free manner. So, and when you talk about the open source, you get the privilege of having a source code. You can revamp the source code. You can do certain tampering into it, or you can customize it in your format. So this is the beauty of the open source software, or the operating system. So it's not like that open source software is meant for the operating system or the application software. It is used for for many things. Like there are certain application software which are in open source, so you get the source code and other things. Now what we have observed that as I had told you that system software role is helps in booting. So booting in a computer means that where the term comes from and what happens exactly during the boot process. Because what we observe that there are certain boot sequence. The action of loading an operating system into memory from a powered off state is known as booting or bootstrapping. When computer is turned on, it first executes code stored in firmware component known as BIOS, that is basic input and output systems, and often performs power on self-test, that is post to detect hardware configuration. So what we have seen that if you have got a CPU, then you have got a BIOS, then you have got secondary loader, then operating system. So this is the modus operandi by which the things are going to be formulated, and if you go more into the depth of this BIOS, you will find out the first is BIOS is loaded, then second is power on self-test post is completed, then you have operating system is loaded, then system configuration is accomplished, and finally system utilities are loaded and user authenticated. So this is the cycle by which the particular figure moves, starts with the BIOS and then end to the user. So what exactly the booting is, when you boot the system boots, then you get a platform, you get a desktop, and from there you are in a position to run the application software. Either it could be Internet Explorer or Google Chrome or whatever it could be. Sometimes we do word processing, we develop presentations, we do spreadsheets, make all those things. So this is part of MS Office, and you will find out these are considered as application software. On the other hand, there are certain emailing software, like Google is providing a Gmail service. So this is again the application software especially confined for the mailings. So process of starting or restarting a computer is called booting, and there are two kinds of booting, that is cold boot and warm boot. So when you talk about the cold boot, process of turning on a computer after it has been powered off completely, that is called cold boot. And when you talk about the warm boot, a process of restarting a computer that is already powered on. So this booting is quite important, because if the system is not going to boot properly, the purpose of the system software is not going to be solved. So there are certain classifications of operating systems. They are multi-user usage, they are multi-processing, they are multitasking, multi-threading, and real-time. Why the real-time model is coming up? Because there are certain the operating systems which are now coming up in a cloud mode. So very easily you can do the things like when we talk about the application software, or take example of comparing MS Word with the Google Drive. What we observe that Google Drive is more on a real-time basis. You can get a file on a cloud, you can work on it, you can save it, and it's follow the multiple usage philosophy, where multiple users can work on a single file at different places. So this is called the real-time model. And when you talk about the multi-users, it's allow two or more users to run program at the same time. Some operating system permit hundreds or even thousands of concurrent users. So there are certain servers, there are certain clients, and these concurrent users are working on a multi-user mode basis. Then supports running on a program more on the one CPU. Then multitasking allows more than one program to run concurrently, and then multi-threading is there. So what we have observed that it's allowed different parts of a single program to run concurrently, responds to input instantly. General purpose operating systems such as DOS and Unix are not a real time thing. So there are two kinds of operating system. One is for the desktop and computers, as I have talked about, or laptop. Another is used for the mobiles and smartphones. So right now the trend had been changed, and in the coming years you will find out maybe the single operating system can come, which can use for the smartphones and for the computers. But right now it had been distinguished for mobile phones we have got Android, and for desktops and laptops we have Windows, which is frequently used. On the other hand, I told you there are certain operating systems which are in open source mode. So those who are not in a position to pay, buy the software, or not able to pay the license fee, they can go for the free and open source software, which is developed by Linux, Red Hat, or other things. Macintosh is one of the open source software. So Microsoft Windows is a series of software. We all know that Windows had dominated this operating system market from last many decades, and most popular OS is that. And so it works on, initially it was working on the disk operating system mode, but right now the model had been changed, and whole the softwares is moving from DOS based to disk operating system based to GUI based. That is graphical user interface. So it's embedded, compact, and it follows certain things which are there. And on the other hand, we have mobile operating system. So mobile operating system, also called mobile OS, is an operating system that is specifically designed to run a mobile device, and it is operating system which is in two-in-one PC that can convert a laptop mode or detached work as a tablet mode. So while computers such as typical laptops are mobile, the operating system which usually used on them and are not considered mobile ones, and as they originally designed for desktop computers, and having a mobile features. So the most popular OS when you talk about the Windows is there, the Mac is used for the Apple, and Linux is freely distributed open source operating system that runs on number of hardware platforms. And the Linux kernel was developed mainly by that purpose only. And when you go more into the depth of this Android, you will find out Android have got a different version starting from alpha. Then it was based on the desserts, inspired names like Cupcake, Donut, Eclairs, and other model is coming up, Oreo, and a lot of models coming up. So the intention is very clear that this Android features mobile is going to be quite customer friendly, quite customized, and it can do the things in a different manner. On the other hand, there are operating systems which are developed for the particular machine, like Apple iPhone OS and Macintosh are there. When you talk about iPhone OS, it is for the Apple smartphones, and when you talk about the Macintosh, it is for the Apple desktops and laptops. So Apple phones are originally developed for use of its iPhone device, and it have got a very rigid things which is developed for the particular machines. So what we have observed that when you go more into the depth of what are the evolution of operating system, then it is bifurcated into three things, that is serial processing, batch processing, and multi-programming. So if you see the serial processing is an ordinary computer does one thing at a time, so it does things in a distinct series of operations. That's called serial processing. It's a bit like person sitting at a grocery store, checkout, picking up items from the conveyor belt, running them through the scanner, and then passing them on for you to pack in your bags. So serial processing it does not matter how fast you load things onto or how fast you pack them. The speed at which you check your shopping is entirely determined by how fast the operator can scan and process the items, which is always at one time. So since computers first appeared, most have worked by the simple serial processing. So this is the thing which is there. And when you talk about the batch processing is a technique in which an operating system collects the program and data together in a batch before processing starts. So an operating system does the following activities related to batch processing. The OS defines a job which has predefined sequence of commands, programs, and data as a single unit. So batch processing technique is for automating and processing multiple transactions wherever we find out the numerous transactions involved, and so batch processing impact is quite high, and because it works as a group, and batch processing helps in handling tasks like payroll, end of month reconciliation, or settling trades overnight. So this is difference between serial and batch processing. So serial processing runs in a sequential manner, that is a predetermined sequence by the processor, and only one process is served at a time. On the other hand, batch processing is one in which multiple process and tasks are handled at a single instant. So this is the difference between serial and batch processing, and we observe that wherever we find the role of masses is there, the numerous transaction involved, this batch processing comes into picture. On the other hand, we have seen that multi-programming is there, and we observe that in ordinary computer does not one thing at a time, so it does things in distinct series of operations. That's called serial processing, and since computer first appeared, most have worked by simple serial processing. So it does not matter how fast you load things onto the belt of how fast you pack them. The speed at which you check out your shopping is entirely dependent by how fast the operators can scan and process the item, which is always one at a time. So multi-programming technique is somewhat having an edge when you compare with the batch processing, because there are certain difference between the batch processing and multi-processing. If you talk about the batch processing, grouping of several processing jobs to be executed one after another by a computer without any user interactions, whereas on the multi-programming ability of an OS to execute multiple programs at the same time on a single processor. So batch processing is slower, multi-programming is faster. CPU might stay without performing at a task if you talk about the batch processing, whereas in CPU, in multi-programming, CPU always perform a task. In batch processing, what we observe that it helps to minimize human interaction and cost, and whereas in multi-programming, it provides maximum CPU utilization. So this multi-programming technique is quite good, and the way things are moving in a real-time manner, the way things are going in that way, there's a great use of multi-programming. So it handles input and output process. It sends message to each. There are certain functions of operating system. What we observe that the input and output process are quite handled very easily. It sends message to each application or interactive users about the status of operation at any errors. It can offload to the management of what are called batch jobs, so that initiating applications is freed from the work. It can manage how to divide the program in parallel processing. So what we observe that when you go more into the depth of the categories of operating system, we have embedded operating system used in handheld computers, stored with device in read-only memory. Then there are certain client operating systems. So these are the operating systems which are there. And on the other hand, when you go more into the depth of this operating system, you will find out there are certain types of operating system which is quite important. So one is batch operating system, then you have real-time operating system, then you have time-sharing operating system, then personal computer operating system, then network operating system, parallel operating system, and finally the distributing operating system. So we will definitely throw a light on all these operating system in a more elaborative manner. If you talk with the batch operating system, in this OS the user did not interact directly with the computer systems. In this operating system, what we observe that the output from each job would send back to the appropriate programmer. In this execution environment, the CPU is often idle because the speeds of the mechanical I/O device are initially slower than those of electronic device. And operating system major task was to transfer control automatically from one job to the next. The operating system was always resident in memory. So what we observe that we have users at one end, then we have CPU at other end, and in that the batch operating system is going on. So if you go through more into the depth of this operating systems, you will find out there are certain advantages, there are certain disadvantages. So advantages is that batch processing takes much of the work of the operator to the computer. Increased performance, as a new job gets started as soon as the previous job finished without any manual intervention. So there is no question of the lead time. The lead time is very low, and somewhere you find out it's almost next to negligible. So there are certain disadvantages also. Difficult to debug program. A job could enter at infinite loop. Due to the lack of production scheme, one batch can affect pending jobs. Examples, there are certain examples also. What we observe that IBM 0S360 is a popular batch processing system. So which had certain issues. So this is there where the batch processing operating system is there. Now the second is a real-time operating system. If you talk about the real-time operating system, is an operating system intended to serve real-time applications that process data as it comes in, typically without buffer delays. Processing time requirements are measured in tenth of seconds or shorter increments of time. So RTOS, which we usually call real-time operating systems, are bifurcated into task scheduling, task synchronization, and then task dispatching. Because you first schedule the things, then you synchronize. Synchronizing means like how how the technology is going to be recapitulate, like how you're going to synchronize the hardware with the software, or with the the programming which had been done. Because so there the synchronization is very important. Then dispatching the things, because once the thing dispatched, then the operating system executed. So what we have observed, that these real time systems interact predictably with events in the outside world, and the good examples are the flight control system, collision avoidance system, satellite guidance system, patient monitoring system, and control system for synchrotrons. So real-time operating system free the application programmer from writing code for task scheduling and dispatching, managing time sharing of processor for a number of different tasks, and interrupt sources while adhering to the strict time constraints. And it is widely used in all kinds of applications, both for PCs and in embedded systems. So it have a generally operate unattended, consequence of failure can be catastrophic. So time sharing means the sharing the time among the process. So when there are more processes and each process wants to load onto the memory and each process wants to execute on the CPU, then what operating system can do? So there is a great use of time operating system. And time sharing systems are the interactive systems and support the multi-processing and multi-programming. We have seen that how this serial, then batch, and then multi-programming was there. And there is a great use of multi-processing and multi-programming. And the time sharing system allows multiple users to access and to share the computer concurrently. The time sharing system can execute multiple processes together at the same time. So if you go more into the depth of this time sharing operating system, you will find out all Windows operating system are multitasking, but some versions only allow one users to use the operating system at one time. And that all multitasking operating system can be time shared. So therefore, so for the certain time, the one user can use, for the other time, the other user can use. So there are three users working on the same operating system, and suppose there are three processes. The processes, one is for user 1 and process 3 for user 3. Keep in mind that a time sharing operating system will manage all these processes in such a way that every user feels that all the operating system is dedicated to him, but actually it is not dedicated. We can load multiple processes together on the main memory. So what we have observed, that time sharing is providing a flexibility to different users to work on the same operating systems in a different intervals. So the main difference between time sharing and the real time operating system is that in time sharing OS the response is provided to the user within a second, while in real time OS the response is provided to the user within time constraints. So in time sharing operating system, quick response is emphasized for a request. So there are certain advantages of time sharing operating systems. There are many advantages of time sharing operating system. Like some of the most common advantages are the time sharing system helps to reduce the CPU idle time. Time sharing system improve response time. Time sharing system avoid duplications of software. So on the other hand, there are certain disadvantages. Some common disadvantages of time sharing operating systems are that when we share the time among different processes, the problem of reliability can occur. Some questions of security and integrity of data in time sharing systems are still under questions, but there are some challenges for time sharing systems. If the multiple processes in the systems, then each process can interfere with each another, and sometimes this is not good situations. If you talk about the personal computer operating system, after a PC boot, you can control it through an operating system. As of this writing, most non-Apple PC run a version of Microsoft Windows or a Linux distribution, as I was talking on. These operating systems are designed to run a various kinds of PC hardware, like Mac OS X is designed primarily for Apple networks. or the Apple computers. So on the other hand, we have got network operating system. So network operating system is an operating system that manages network resources, essentially an operating system that includes special features for connecting computers and device into a local area network. On the other hand, we have got parallel operating system. Those parallel operating systems are the interface between parallel computers and the applications. They translate the hardware capabilities into concept usable by programming language. And on the other hand, we have got another distributed operating system. So these distributed systems are multiple central processors to serve multiple real-time applications and multiple users. The role of distributed operating system is quite frequent in nature, because the way things are moving in a real-time mode, there is a great use of it. So data processing jobs are distributed among the process accordingly to which one can perform each job more efficiently. So with resource sharing facility, user at one side may be able to use the resource available at another, and better service to the consumers, reduction to the load on the host computer, and reduction delays in the data processing. So I think if you talk about the operating systems, role of operating system is quite vibrant, because if there will be no operating system, or the operating system is not working on a real-time mode, ultimately there will be a chances that application system software is not going to perform well. So no doubt that the impact of the application software is more towards the customization, whereas the impact of the system software or operating system is to more help in rebooting the systems or booting the system in such a manner so that things can be interrelated. Sometimes it can enhance the speed of the hardware also. So the compatibility and adaptability and acceptability is quite important when you talk about the operating systems. I think the backbone of any hardware is the software, and when you go more into the depth of it, you will find out that it is the system software and application software which is quite important, and it varies from the circumstances to circumstances, and varies from situation to situations. So for the particular machine, this operating system is quite good, whereas for different machines the different model is there. So that is where type of operating system is going to play a very vital role. As far as this CIT course is concerned, this is quite important for the learners, because they are going into the basics of the computer and information technology. So this hardware and software role is quite important. Thank you very much.